A black hole does not just trap light. It implies that the 3D reality you live in is a projection of information on a distant 2D surface, and that your entire existence is encoded in a boundary you can never see. That is not science fiction. It is the only explanation quantum gravity has left for what happens to information at a black hole's edge, and it is being actively tested right now. Start with the paradox that has haunted physics since 1976. When something falls into a black hole, general relativity says it is crushed at the singularity and lost forever. The information describing that object, every atom, every quantum state, is gone from our universe permanently. But quantum mechanics says information can never be destroyed. These two rules collide at the event horizon, and for 50 years, no one has found a way to make both true at once. Stephen Hawking made the conflict explicit in 1976. He showed that black holes emit thermal radiation, Hawking radiation, because of quantum effects near the horizon. The radiation is purely thermal. It carries temperature, but no memory of what fell in. So a black hole eventually evaporates completely, and whatever was inside is replaced by featureless heat. The information is lost. Quantum mechanics breaks. The only way out was first suggested by Jacob Bekenstein in 1972, refined in the 1990s by Leonard Susskind and Gerard Souft, the holographic principle. Their finding, supported now by thousands of calculations, is that the information content of any volume of space is not proportional to its volume, but to the surface area of its boundary. A black hole's entropy is exactly 1/4 of its horizon area, measured in Planck units. That is not a rough estimate. It is precise to the factor. If the information is preserved, it must be stored on the horizon itself, not inside. The interior of a black hole is not a separate region with its own independent physics. It is a projection of degrees of freedom that live on the 2D surface of the horizon, encoded like a hologram. In 1997, Juan Maldacena published AD-CFT, the anti-de Sitter/conformal field theory correspondence, the first concrete mathematical proof that a theory of gravity in a 3D volume is exactly equivalent to a quantum theory without gravity on its 2D boundary. The interior of a black hole and the exterior of a black hole may be two descriptions of the same information. In 2019 and 2020, physicists, including Ahmed Almheri, Donald Marolf, Joe Polchinski, James Sully, and others, resolved the specific mechanism through quantum extremal surfaces and the Page curve. The information is not lost. It is encoded in the Hawking radiation gradually, through entanglement between the black hole and its emitted particles. When enough radiation has escaped, the information becomes recoverable. The disturbance this causes is philosophical and physical. If your 3D reality is a projection of 2D information, then space and time themselves are not fundamental. They are emergent. They are patterns of quantum entanglement and information arrangement, not a pre-existing stage on which physics plays out. This is not abstract philosophy. The Event Horizon Telescope has now photographed black hole shadows twice, M87 and Sagittarius A, confirming the predictions of general relativity with extraordinary precision. But those images only show the exterior. The information paradox operates exactly at the boundary where the image stops. We cannot observe the horizon's encoding directly. We can only measure that the math requires it. And that is the disturbing conclusion. The universe you experience as solid, three-dimensional, continuous, and local is likely a decoded projection from a much stranger reality at the edge of every black hole. Follow for more on the physics that rewrites reality. And tell me, if your entire 3D existence is encoded on a 2D surface, does that change whether you feel real